This modification, however, introduces a critical engineering trade-off. If we look at the core physics, changing the material changes the entire structural behavior of the assembly. Let us open this development dilemma to the floor. Imagine you are leading the engineering review for this vehicle's dynamic setup. Based on your area of expertise, how would your department solve the following engineering conflicts? The dynamics and reliability perspective, fatigue life, track-induced inputs expose the steering assembly to continuous high-frequency vibrations at 500 Hz. Unlike titanium, which possesses a distinct endurance limit, 7000 series aluminium experiences continuous cumulative fatigue damage over time, even under low-stress amplitudes. The challenge: how do we mitigate the risk of catastrophic fatigue failure at the telescopic coupling without adding dead weight back into the system? Defend your engineering approach in the comments. Would you alter the component's cross-sectional geometry to shift its natural frequency away from resonance, or would you introduce an elastomeric damping interface? You can evaluate the core mathematical breakdown for this cycle analysis in Equation 1 within our technical index graphics. The crashworthiness and safety perspective, nonlinear dynamics. In a real-world crash scenario, impact forces are rarely perfectly axial. A severe frontal collision introduces simultaneous bending moments and torsional shock waves into the column structure. The challenge: when switching to the more compliant aluminium sleeve, how do you prevent localized plastic buckling of the housing before the shear pins can cleanly reach their 10 kN release limit? Outline the equations governing the energy dissipation rate required to ensure the telescopic collapse remains purely axial under complex multi-axial loading. The entire differential calculus model for this collapse is detailed under Equation 2 in the technical reference block. Lay down your analytical arguments and structural equations in the comments section below. The most rigorous, engineering-backed solutions will be pulled into the laboratory whiteboard for deep dive evaluation in our next segment. All full-scale reference diagrams, material graphs, and mathematical models are provided as a complete index suite at the end of this broadcast for your detailed verification. Make sure to subscribe so you do not miss the engineering outcome in video 8. I will see you in the laboratory.